Hi, in this video, we're going to talk about configuring IPv4 static routes. So here's the topology that we're going to be using. All right, looks like an IPv4 topology to me. All right, so first thing we're going to do is verify the routing table in R1. Right now we have configured no static routes and there's no dynamic routing protocol running. So as we can see, R1 only knows about its directly connected networks. Okay, and the same thing for R2 and R3. They only know about each other's directly connected, their own directly connected networks. All right, so let's try and verify connectivity to R2. Okay, so if on R1, if I try pinging 172.16.2.2, this interface right here, what do you think? Is it going to be able to ping it? Well, if R1 knows about this directly connected network, okay, so it's, which it does because it's directly connected to it, and we verified that previously. So this is just another address on its link. And as long as this link is up between R2 and R1, it will send packets back because it's the source of this ping is also on this same network. It's coming actually from the 172.16.2.1 address. So that should succeed, and it does. All right, so that's the one thing we always want to be able to verify. Whenever troubleshooting either static or dynamic routing, first of all, can you ping your neighbor? Because if you can't do that, then there's something wrong. You either have an addressing problem or physical link problem or something's going on. But it's you got to solve that before you solve the routing. All right, what if we try pinging this remote network, this remote address here, 192.168.2.1 from R1. Okay, well, as you can see here, it fails. Okay, and the reason why is R1 does not know how to forward packets to the 192.168.2.0 network. All right, so we're going to configure some static routes. And there's several types of standard static routes that we can use. One is the next hop static route. That's the one that we use the most. That's just using a next hop IP address. So in IPv4, we say IP route, then the network address and subnet mask. This is the network address and subnet mask of the remote network. Okay, and then we're going to give typically a next hop IP address. Really, it only has to be an IP address that is reachable, that the router knows how to get to from an entry in its own routing table, but should always be a next hop address an address on one of its own directly connected interfaces, unless you have another reason to do so. All right. There's also what we call a directly attached static route. This is where you only use an exit interface, and this is not recommended anymore. Okay, I'll talk more about that when we get there. There's also what's known as a fully specified static route, and you really only need this when Cisco Express forwarding, which I'll talk more about later, is not enabled, or in IPv6 when we're the next hop address is a link local address. We'll talk more about that when we talk about configuring IPv6 routes. Okay, so first of all, Ceph, Cisco Express Forwarding, has been enabled by default since iOS 12.2. And I've talked about Ceph in a couple of other videos, and I'll mention it here again shortly. All right, so let's go ahead and continue here. Let's just look at the next hop address. Okay, so here I'm going to create 3 static routes for the 3 remote networks. Notice that they're all using the same next hop IPv4 address. Right? So that's pretty straightforward. Okay, if I do show IP route in the routing table, I can see, well, there's one of the static routes. Let me just kind of show you an example here. When I did the IP route 192.168.2.0, 255.255.255.0, 172.16.2.2. Let's take a look at this static route in the routing table. Okay. Now, a recursive lookup would only be required. I'm going to explain what that is when Ceph is disabled, Cisco Express Forwarding. Now, Ceph is enabled by default starting with iOS 12.2. So we really don't worry about this too much anymore, but let me explain what a recursive lookup is. So what if there was a packet going to the 192.168.2 dot something network? Okay, the routing table would find that best path and the longest match in the routing table right here. It would say, okay, what's the next hop address? Oh, it's 172.16.2.2. Okay, where is that? Remember, it needs an exit interface. What interface am I sending this out of? Because I've got to know that and also encapsulate it in that proper layer 2 encapsulation and forward it out that interface. So it looks up 172.16.2.2 and it says, oh, there it is. It's directly connected network. And it's going out my serial 000 interface. So we call this a recursive lookup. It actually has to do 2 lookups for the route. Now, this is no longer the case with Cisco Express Forwarding. Cisco Express Forwarding, all this information, the routing table and the adjacency information is pre-populated in something we call the FIB, Forwarding Information Base and Adjacency Table. So basically, when the route is looked up, the destination IP address, and it finds it in the routing table, that entry, the adjacency table also contains the egress exit interface. So all that information is right here, and it can forward it on its way very quickly, all done via the data plane, which is done in hardware, as opposed to the control plane, which is done in software. Okay, so we don't have to worry about those recursive lookups anymore. But something before we kind of continue here, just a reminder, remember those Alexander's routing table principles I always like to talk about? Principle 1, every router makes its decision alone based on the information it has in its own routing table. The fact that one router has certain information in its routing table does not mean that other routers have that same information. And routing information about a path from one network to another does not provide routing information about the reverse or return path. Okay, so what does that mean? That means we have to configure static routes on R2 and R3. Just configuring the static routes on R1 doesn't do us any good. So let's configure R2 static routes for both of the remote networks in our topology. And we can verify that looking at show IP route. There they both are. And let's do the same thing for next hop static routes on R3. Okay, so R3 has to know about 3 remote networks. We can verify that in the routing table as well for R3. Okay. So let's now verify that we have connection from R1 to R3. We do that ping again, and this time our ping succeeds. All right. Now let's take a look at that directly attached static routes that we no longer use anymore or no longer recommended. Okay, and the reason why this can cause problems, even routing loops. Okay. So it used to be that we'd use this with point-to-point serial links, but again, no longer recommended when using Ceph. Okay, actually, if you're going to do it and Ceph is not enabled, we're going to use a fully specified, which I'll talk about next. But let me show you an example of this. So this is how sometimes this is how we used to recommend, either properly or improperly recommend it, but this is what it looks like. So notice we're just using an exit interface, not a next hop address. Okay, and the idea here, and we'll take a look at this why in a moment, is that in the routing table, notice that it says what the exit interface is, serial 000. So you wouldn't have to do a recursive lookup. Okay? But as I mentioned, this could cause potential routing loop problems. So we really shouldn't be doing it this way, even with Ceph disabled. All right, but there is something I do want to mention here. Notice that it says directly connected here. Okay. These are not directly connected networks. These are static routes. And there's some misinformation floating around out there about this, that some people have stated that these static routes that say directly connected here have an administrative distance of 0. They do not. They still have an administrative distance of 1. Only a directly connected network can have an administrative distance of 0. Okay. All right. So if you are going to do it this way, or let's say you have an Ethernet network here, but if you really need to do it, if Ceph is disabled and you want to use the exit interface, not have the recursive lookup, or if you're on a multi-access network like Ethernet, you do this. You say IP route, the destination network subnet mask, the exit interface, and the next hop IP address. Okay, this is known as a fully specified static route. And we're going to see with IPv6, there's a time when you must use this. We'll talk about that in a later video, one that's coming up. All right, so here we verify the routing table. Notice it has both the next hop IP address and the exit interface. All right, so we can look at just static routes in the routing table. If you do show IP route static, this will only show you the static routes in the IPv4 routing table. Okay. If you want to find a specific entry for any IP address, not even network address, can be a specific address. For example, show IP route. Hey, how do I get to the 192.168.2.1 device? Hey, well, what this will do is actually show you how it's known in the routing table. It says, I have a routing entry for that, and it actually shows the network address and subnet mask that it shows that it would have in its, that it does have in its routing table to reach this specific IP address. It says, hey, it's a static route, administrative distance of 1. All static routes have a metric of 0. Okay, you can also look at the static routes that are configured in your running config without just doing show running config and paging through lines of configs. And this can actually be a problem on large networks, just doing show running config. Talking to a friend of mine yesterday at a place he works, and they have a very well-known content provider. I won't mention, but they're running config on their router that also works as part of a firewall. 10,000 lines of code just for the access control lists on there. All right. Anyway, show running config pipe. This means filter what I'm about ready to show you and show me the section that begins with IP route. So we'll just show you the IPv4 static routes in the running config. Okay, configuring a default static route. Okay, so quad 00, this first quad 0, is actually says I'm going to match any network, and the second quad 0 is the subnet mask. It means really matches any subnet mask, but really what this means is 0 bits need to match for this to be a match. This is the key here, this quad 0 in the subnet mask. So if you want to use this route, 0 bits need to match. Okay. So we can configure, in this case on R1, we really don't need all these different static routes here. We could actually remove those with the no IP route command, or static routes to these 3, because everything is being sent to R2. So we could actually just have a default route, say, hey, send everything, if it's not on one of my directly connected networks, okay, send it to router R2. Okay. By the way, default static routes are very commonly used with dynamic routing protocols. Okay, you might have a default static route on R1, let's say, pointing to R2, let's say it's its ISP, and within R1 routing domain, is many routers, let's say, running OSPF dynamic routing protocol. But on R1, which says, look, if it's not in our routing domain, I'm going to be sending those packets up to our ISP, R2. And that default route can actually be advertised within the dynamic routing protocol's routing domain, in this case, OSPF, to tell all the other routers, hey, I'm our way out of here. I have a default route. And they would actually see that default route via the dynamic routing protocol. In this case, my example here, OSPF. Okay. So a default route is, if a default route is not implemented and there is no match in the routing table, then the packet would be dropped. If there is a default route, then it's, look, it's not my problem. I don't know exactly where this network is, but I'm going to send those packets to, in this case, R2. Okay, and we can use our show IP route static. There it is in the routing table. All right, and that's a little bit on configuring IPv4 static routes.